Welcome to our formal exploration of set theory. Consider the universal set U, defined as the set containing the elements 1, 2, 3, 4, 5, 6, 7. We have three specific subsets. A is defined as the set containing 1, 3, and 5, B as the set containing 2, 4, and 6, and C as the set containing 3, 4, 5, 6, and 7. Our goal today is to verify the statement A intersection B union C equals a union C intersection B union C. First, we find A intersection B. This is represented as the set containing 1, 3, 5 intersection the set containing 2, 4, 6. The result is an empty set denoted as phi. Now, we calculate A intersection B union C, which is the empty set union the set containing 3, 4, 5, 6, 7. This simplifies to the set containing 3, 4, 5, 6, 7. Next, we evaluate a union C, which is the set containing 1, 3, 5 union the set containing 3, 4, 5, 6, 7. The result is the set containing 1, 3, 4, 5, 6, 7. Now we calculate B union C, which gives us the set containing 2, 4, 6 union the set containing 3, 4, 5, 6, 7. This results in the set containing 2, 3, 4, 5, 6, 7. Finally, we find a union C intersection B union C, which is the set containing 1, 3, 4, 5, 6, 7 intersection the set containing 2, 3, 4, 5, 6, 7. The intersection yields the set containing 3, 4, 5, 6, 7. In conclusion, we have shown that A intersection B union C equals a union C intersection B union C, both resulting in the set containing 3, 4, 5, 6, 7. Thank you for watching this formal examination of set theory. We hope you found it enlightening.